So just as we talked about in the previous lesson, that whenever there is a radioactive decay, two things must take place. One, the element must change from one to another. So the parent produces what? A daughter. Then two, one of the rays must be produced. So today we are looking at beta decay. When we say beta decay, it means the parent produces a daughter, and then on top of producing the daughter, a beta particle is also produced. So we are saying when a parent nuclide X, if the parent is called X, decays by beta emission, what happens? The atomic number of the daughter, and we are calling the daughter Y, the atomic number of the daughter increases by 1, and its mass number does not change. So let's look at this equation. Suppose we say the parent is called X and the daughter is called what? Y. And because this is beta decay, a beta particle must be produced. We say the beta particle is an electron. Some time back we looked at properties of alpha particles, beta particles, and gamma rays. So this is how you write a beta particle. It is an electron. The mass number is 0. The atomic number is 1. It is negative because electrons are negatively charged. All these decays, energy is what? Produced. So some energy is produced, although sometimes when we are writing the equation we ignore this, but what we know, energy is one of the products. So in these radioactive decays, the parent produces the daughter. On top of the daughter there should be a ray which is produced, whether it is a beta particle if it is a beta decay like in this case, or alpha particle if it is a alpha decay, or gamma rays if it is a gamma decay. Now we are looking at a beta decay, so this is a beta particle plus energy. So automatically we know that the parent must have atomic number, that is Z, mass number is what? A. So what happens now to the daughter? We said, let's go back, we said the atomic number of the daughter, which is Y, increases by 1, and its mass number does not change. So when we say the mass number does not change, it means the mass number for the parent is the same as the mass number for the daughter. If this is 60, this is 60. If this is A, this is also A. But atomic number increases. So if this one was Z, the daughter will have Z plus 1 to increase, to add. So if this one was having atomic number 6, this one will be 6 plus 1, which will be what? 7. You see, this is the parent nuclide, this is the daughter, and this is the beta particle plus what? Energy. Let's look at an example of such a decay. Here we have a neutron. A neutron is letter N. It has atomic number 0. The mass number is 1. So if a neutron decays by producing a beta particle, you see this is a beta particle because it is a beta decay. When you balance, this will be the daughter. The daughter will be a proton. We said the atomic number, the mass number does not change. If this is A, this is A. If this is 1, this is 1. What about the mass number? If this one is 0, this one will be 0 plus 1, which will be 1. So you can see the mass number, the atomic number rather, has increased by 1, but the mass number does not change. So this is a good example of a reaction involving beta decay. Now let's look at a question which can be set. Sample question. It says carbon 14, there are two, by the way, carbon has two isotopes, carbon 12 and carbon 14. The atomic number remains 6, but the mass numbers are different. When we say carbon 12 and carbon 14, it means we are separating them by mass numbers. The atomic numbers remain 6, but the mass numbers change to 12 and 14. So the one which is radioactive is called carbon 14. So carbon 14, you write it like this. C means carbon, atomic number 6, mass number. So this is the parent. It decays by emission of a beta particle. So a beta particle is one of the products. And this person is asking that we should write down a balanced equation for the decay. Write a balanced equation for the decay. Then secondly, that is B. He wants us to name the daughter. What is the daughter nuclide? So we shall put here as part of our solution, we shall say the parent is already known, that is carbon 14. It produces a daughter which we don't know, we can call it even Y, plus a beta particle, which we know how to write. Now, if that is our equation, what did we say during a beta decay? We said the mass number remains. So if this is 14, this one is also 14. Now here I have said N because I already know what it is, but you could call it Y. You don't know it. But the mass number we say does not change. 14, 14. But atomic number increases by 1. So if this is 6, this one becomes 6 plus 1, which is what? 7. So you would have here 14. Here it is 7. Then you call this one what? Y. You can even call it W. You see? So this is the balance equation, because when you add 0 plus 14, you get 14. You balance on both sides. When you get 7, you add it to -1. You get what? 6. Now let's go. We have balanced the equation. Now we are supposed to name the daughter. So this is the daughter. So for us to name the daughter, we don't look at the mass number, we look at the atomic number. Which element in the periodic table has atomic number 7? And that element we know is called nitrogen. So we shall quote by saying, from the periodic table, the element which has atomic number 7, that is now our daughter nuclide, is called what? Nitrogen. So this is how you get all your marks. You are better than somebody who says the daughter is called nitrogen. You quote, where did you get the answer from? From the periodic table. So if you know that it is nitrogen, and nitrogen the symbol is N, instead of writing here Y, you just write here what? N, the way I have already written. Now in a gamma decay, when a parent is called X, decays by gamma emission, that means gamma rays is produced. Both the atomic number and the mass number or atomic mass, they don't change. So let us look at this. If X is the parent, Y is the daughter, and then a gamma ray is produced, all these decays energy is what? Given out. Gamma rays, this is how you write it. It has atomic number 0, mass number 0. What did we say? That the mass number of the parent and the daughter don't change. So if this is A, this is also A. If this is 10, this is 10. The atomic number also does not change. If this is Z, this is Z. If this is 3, this is also 3. So let us look at an example. Look at this. This is the parent. The parent is called what? The parent is called cobalt. Atomic number 27, mass number 60. It produces a daughter which has also the same atomic number and mass numbers plus gamma rays. When you add 0 to 60, you get 60. When you add 0 to 27, you also get 27. So this is a good example of an equation involving gamma decay. So we have laws of radioactive decay using what we have already discussed. The first one says, when an element decays by emission of alpha particle, it turns into a new element or another element 2 places lower in the periodic table. So we are giving a general conclusion now using the laws that if it is an alpha decay, the atomic number reduces by 2, mass number reduces by 4. So if the atomic number reduces by 2, it means the new element will be 2 places lower in the periodic table. What about beta decay? When an element decays by emission of a beta particle, Okay, it turns into an element one place higher in the periodic table. We said in beta decay, atomic number increases by 1, mass number does not change. So since the atomic number increases by 1, it means the new element will be one place higher in the periodic table. Okay, now let's conclude with this sample question. Study the radioactive decay series below. Just look at this. This parent produces the daughter. This parent also produces the daughter. This one also produces the daughter. It is like your father, your grandfather produces your father. Your father maybe produces you. Then you also you produce another person. This is X, this is Y, this is Z. I want you to simply look at the mass numbers and the atomic what? So you look at the parent, the daughter, the parent, the daughter. So we are supposed to look at that equation. So here there is a ray which is produced. You are yet to tell us whether it is alpha, beta, or gamma. So this ray is A, this ray is B, this ray is what? C. So we are supposed to identify the radiations A, B, and C in the decay process above. Simply look at the atomic number of the parent and the daughter. The atomic number is reduced by 2. Then the mass number, when you subtract, is reduced by 4. So this should be alpha particle. That is A. Look at this parent and also the daughter. The atomic number has increased from 88 to 89. It has increased by 1. The mass number does not change. So B becomes a beta particle. Look at this, the parent and the daughter. The atomic number does not change, 89, 89. The mass number also does not change. So this should be gamma rays. So that will be the solution. Then B, state two similarities between radiations A and C. So in a solution, we said A is alpha particles, B is beta particles, C is gamma rays. Now, question B is asking for similarities between radiations A and C. What is radiation A? Alpha particles. What is C? Gamma rays. What is the similarity? So you look at their properties. Both alpha particles and gamma rays cause fluorescence. Both alpha particles and gamma rays affect a photographic plate. Where do we get these answers? You go back and look at the properties of alpha particles, beta particles, and gamma rays, which we studied some time back. Using those properties, you can state the differences if the examiner wants. You can also state the similarities. If somebody asks for the differences, you would say gamma rays have no charge, while alpha particles are positively charged. All these properties are there. Remember, we looked at them some time back.